This is 3.5 day 2, and we're going to continue writing equations for graphs. Writing equations for lines. And today we're going to focus in on the parallel and perpendicular lines. So we're going to use both of the same forms that we used before. You can either use slope-intercept, or you can use point-slope. Whoops, I got distracted by the bell ringing. Hold on. Equal sign m and then x minus x1. So again, you can choose either one that you want to use, whichever one's kind of becoming familiar or easy to you. Pick that one and just stick to it. So this one says write an equation of the line passing through this point. So there's my x and y. That is parallel to the line with the equation y equals mx plus b. So this 2x minus 1 matches this form. So that would be my slope, and that is my y-intercept. We can cross that off right away because that we cannot use in any part of our problem. The only thing we get to use is our slope. So this line exists out there. I'm just going to give it a quick sketch. It crosses at -1 and then it goes up 2. So it looks something like that. Now we're supposed to go through this point, 1, -1, and we're going to make one that is parallel to it. And it will have a completely different y-intercept. That's why I can't use that. So I'm going to do this two different ways like I have been, just so you can see it both ways and you can pick. So I'm going to start with my point-slope formula. So y minus and then -1 equals, my slope is 2 and then x minus 1. So since we're parallel, we're going to use the exact same slope because parallel lines have same slope. So now this is y plus 1 equals 2x minus 2, and then we're going to minus 1 to the other side, and we'll end up with 2x minus 3. Using point-slope formula, that was point-slope formula. This is slope-intercept, so y equals mx plus b. And we know our m, it has to be the same slope. And then we're going to take our point and just plug it in. So I'm going to put the -1 where the y is, and I'm going to put the +1 where the x is, and we are solving for a new b. So -1 equals 2 plus b, and then I'll minus that 2 over, and that's where I'm going to get that -3. Next one we're going to do is going to be perpendicular. So we have to switch our slope just a little bit. So I'm still going to do it both ways. This is still my point, xy, and this is still my slope. But in order for us to be perpendicular, we're going to have to flip that. So if it helps, put that over a 1 so that you have something to like physically flip over. So our new slope is going to flip to be 1/2. And then this is positive, so our new one is going to be negative. So when I set up my equation, I'm going to go y minus 2 equals -1/2 and then x minus 3. We'll do some simplifying here. Y minus 2 equals, I'm going to distribute, so -1/2 x, and then this will be plus 3/2. If you're more comfortable switching these into decimal, please feel free. You don't need to keep them as fractions like I'm doing. You can switch them. In fact, I'll grab my calculator and I'll finish it off in decimal because usually most kids switch to decimal places. So I distributed that plus 3/2. Now we're going to add the 2 over. So I get y equals -1/2 x plus, and then I've got 3/2. So if you have a calculator like this, all you really have to do is do 3 divided by 2, and that will tell you the decimal of that. And then we're going to add 2 to that. So you could do 3.5 here. That would work. The other form, slope-intercept. My slope is -1/2 x plus, and now we need to find our b. So I'm going to plug my point in. 2 equals -1/2, and then our 3 plus our b that we're going to find. So 2 -3/2 plus b. And we're really just doing the reverse math. Instead of adding 2 to the 3/2, we're going to add 3/2 to the 2. In either case, I end up with that 3.5. 2 more, just like that. We're going to do one parallel, one perpendicular. This time, though, the equation I gave you is a little more complicated than just y equals mx plus b. The only way for us to really figure out what the slope is to have it in this form so that we can look at the number right in front of the x. So I first have to take this equation and solve it for y, just so that I can figure out what my slope is. So I'm going to minus that 3x over, and then we're going to divide by 4. Just make sure that you divide each of them by 4. And now I know what my slope is. It's right there. It's right in front of the x. And remember, I can't use the y-intercept, so you can just cross that out. I don't need it. I just needed this slope. So in order to be parallel, we're going to use that slope with our point. So y minus -3, -3/4, and then x minus 4. So this is y plus 3. We're going to distribute, so I get -3/4 x, and then plus, that turns out to be 3. I'll show you how to enter that on your calculator. So if you have -3/4, and that's getting times by -4, and the answer is 3. And then we'll minus 3 to the other side. Oh, that's kind of wild. The 3 and the -3 will go away, so this is just my equation. My y-intercept is technically 0, which you can totally write. I just chose to leave it off. To do this as slope-intercept, we'll do y equals mx plus b. I know my m has to be -3/4 because we're parallel, so I have to be the same, and then we're going to plug our point in. So -3 will go here, 4 will go there, and we're trying to find our b. So -3 equals, and the 4's will cancel, and then when I go to add 3, I will get 0. One more, this time it's going to be perpendicular, but it's using the same equation, so we don't have to do that work again. We just have to flip this. Opposite reciprocal, so our slope is going to be 4/3. From negative to positive, and then flip the fraction over. Do it both ways. So y minus -3 equals, this time we have 4/3. Whoops, that's an x. X minus 4. So y plus 3 equals 4/3 x minus, I'm going to write 16/3. If you want to do it as a decimal, you totally can. So 4 divided by 3, you can get that decimal and then just times it by -4. So your decimal right here could be -5.3 repeating. And then we're just going to minus 3 from that. So y equals 4/3 x, and then we're going to minus 3, so -8.3 repeating. We're going to do it the other way too, so y equals mx plus b. My m is 4/3, and then we're going to put our point in. So -3 equals 4/3 with our 4 and our new b. So this is, -3 equals, this is 16/3 plus b. So we'll minus our 16/3. We're kind of just doing the opposite of that. Instead of having the 16/3 and minusing 3, we have the 3 and we're going to minus the 16/3. In either case, we still come up with that 8.3 repeating. Our last set of questions is just asking which ones are parallel. So in order to decide if they are parallel or perpendicular, you need to know slope. So in this first one, our slope is right there, nice and easy. Our second one, not so easy. We need to solve for y in order to see our slope. So I'll minus the x over, and then we have to divide by 3. And when you divide that x by 3, it's kind of like having 1/3. So that's your slope for this one. You can always add that 1 there because it doesn't really do anything, but it definitely helps you kind of see that slope because then you've got the 1 on top and the 3 on the bottom. Last one, we need to do a little more math. So 3x plus 3, I'll just distribute real quick. And we need it to be y equals, so we're going to get rid of this 2. And I have 3x plus 5. So out of all 3 of these, the slope for these two match. So those are the ones that are parallel. How should I say that? Let's just say line 1 and 2. Or line 1 and 3. They had matching slopes, so they're parallel. This one is perpendicular because it is the flip of those guys and negative.